Okay, so yesterday, first half of the day there was a sub, so yesterday we were catching up, finishing the assignment from the previous day and doing missing work. So you should have your grade in front of you that lets you know what your test grade was from when we took that test, okay? Now, there'll be opportunities to correct it and fix it, maybe tomorrow. We don't have a ton of time today because it's a shorter day on a Thursday, right? So again, on your grade sheet, see where it says test. You can see what grade you got on your test, okay? Y'all know what today is? And? First day of the football season. What'd you say? What? Who? Oh, Queen Elizabeth. I heard about it. It's sad when people pass, yes. But if you have a test in front of you, you need to not have your phone in your hand. You can take that test from me. Borrow one from, make a friend, borrow one. Okay? I'll show you how. Very easy. Do you have a pencil? No. You don't have an extra pencil? Do you 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 have an extra pencil? Alright. Alright, so let's do this warm-up. Number one, we're going to go to the calculator and type in this exponential function. We've been starting to look at exponential functions, and we continue today. So remember, from the on screen, you press number 1 for a new document, do not save, and then number 2 for graphs. Okay? Now, let's type this in, 8 parentheses, 2 parentheses, and then you have to hit caret, which is right here, caret x, to get an x in the exponent. Okay? So once you type that in correctly, you hit enter, and you can see that's an exponential growth. Now, to get a table, I'm going to press Control T. So Control T. Table pops up, and you can just fill that in for your warm-up. Nothing too crazy. Was everyone able to get a table from a function using your calculator? You graph, you hit Control T, okay? All right. Now, we're continuing on through exponentials. We're going to talk about the key features today. Did you get the warm-up? Always do that first, right? Okay, so everyone's got this sheet. Now, you could fold it to make it look like a book, but you don't have to. I think when you fold it, it's easier to lose, so you can just leave it like this if you want. It's up to you. But let's talk about exponential functions. So, you already know some of this. An exponential function is a function where the exponent is a variable. Or x. So again, x is in the exponent of a exponential function, right? You should put it all the way away so we can get this done, please. Rick, you got a pencil? Oh. Alright, now, exponential equation. Let's go ahead and write this down. It's going to be y equals a times b to the x. So y equals a parentheses b to the power of x. A times b to the power of x. Okay, now a is the starting amount. Or the y-intercept. If it's in this form, then the a is the y-intercept. It's what you start with, okay? The initial value. Now b is the rate, okay? It's the rate of growth / decay. So y'all remember, exponential growth and exponential decay depend on this letter b, okay? It's the multiplier, okay? Now, an asymptote, by the way, this word right here, it's kind of a weird word. The P is silent, kind of, so it's asymptote. Asymptote, okay? It is a line that a graph cannot cross. So an asymptote is like a boundary that you cannot cross. You can get super close to it, but never ever touching it, never going past it, okay? And we're going to see that on our exponential graphs, okay? Now, asymptotes are drawn as dashed lines. Dashed lines. Because they are not part of the original graph, okay? So a dashed line looks like this. It's got little breaks in it. Okay. Now, when we talk about exponential growth, okay, the b value is going to be greater than 1 for it to be a growth function. So when we say greater than 1, it could be 2, it could be 1.5, it could be 10. Anything that's greater than 1, if you multiply something greater than 1, it'll grow, okay? Exponential decay, though, is going to be between 0 and 1. So 0 is less than b less than 1. Decay is less than 1, between 0 and 1. So you could have any decimals or fractions that are less than 1. Not negative, but positive. So for example, 0.3, or 1/2, or anything like that. Okay? Anything between 0 and 1 is going to be a decay function. Decay. Now, if you have that written down, I want you to flip it over. Okay, I want you to try these two. It's like the warm-up. You're going to put in the function, give me the table, and then graph the points. Real quick, when you do the table, I want you to use -2, -1, 0, 1, 2. Okay, so show me you can graph it and give me the table, okay? By the way, so graph that, Control T, give me the table. Make sure you give me -2, -1, 0, 1, and 2, okay? And then you want to go to the next page and do the graph. Yeah. Here, see that? See all that stuff at the top? Try this. Yeah, I graph. Number 1, new document, number 1. Yeah, don't save, no. And then number 2, add graph. There you go. Type in there. Okay. So again, yeah, use this. Graph it, hit Control T for table. Make sure you plot the points before you graph it. So again, on your table, make sure you start with -2 to -1, 0, 1. You need a calculator to do this. Sign out. Take that. I put X and Y at the top. Sorry. Yeah. So we do a new document. Don't save. Number 1. Sorry, number 2. My bad. (2 parentheses 3 to the power of X). Control T. Now, your table, like I said, you want to use -2. You want to go back up a little bit. So you got to go left and then up to -2. And that's what I'm going to type right here. 0.2 repeating, 0.6 repeating, 2, 6, 18. And I need you to plot those actual points on your graph. If you're testing, I don't want you to have a phone in your hand, please. Can you put it all the way away, because it keeps happening. Thank you so much. So, -2, 0.2 is like a little bit above. -1, 0.67 is a little past halfway. 0.2, 1, 6, 2, 18. Do y'all see how I am plotting the points from the table onto my graph? Okay. Now, this is going to go through these points, and then it's going to level out. It does not actually touch the line down here, okay? This line is an asymptote, okay? All right, and I want you to do the same thing on number 2. Let's go ahead and do a new document, don't save. And then a new graph. So 1 parentheses. Do y'all know how to make a half? How do you make a fraction in the calculator? Control divide. So 1 on top, 2 on the bottom, caret X. Okay. So make sure you get that down, hit enter. This one you can see is exponential decay. So then you're going to Control T, give me that table. And again, go up to -2 so I can see those values. Go ahead and write in that table and plot those points for me, please. Okay. So for -2, 4, yeah. So yeah, plot those points. -2, 4, put a point. -1, 2, put a point. Okay. So make sure you plot these points. All right. You see how I wanted you to use -2 so you actually have some points on there? So look, you go up. Okay. Yeah. Real quick, because we're doing notes. All right. So I get -2 gives me 4. -1 gives me 2. 0 gives me 1. 1 is 0.5. 2 is 0.25. Alright, so -2, 4, put a point right here. -1, 2, put a point right here. 0, 1, 1/2, 2.25. And I could even go back another step to -3 and get, whoops. -3 is 8. -4 is 16. So you can see those points are exponential. They're decreasing, cutting in half each time, and you can connect those points, okay? Yeah, my sketch is not perfect, but it is what it is. It does not cross this dashed line here, okay? Remember, from the front of these notes, that dashed line is called an asymptote, okay? It does not cross the asymptote. So again, are you able to take an equation, get a table, plot the points, graph it? Okay. Now, on the next section is where we're talking about taking a function, getting the table, and going from there. Okay, so what we want to do is take these points and make a table out of it. So let's go ahead and do that. You can do it off to the side over here. It's fine. So we have x and y. -2, -1, 0, 1, 2. Now, look at -2. What's the y value if it's like barely above it? So again, -2, the point is right above it. It's like a decimal. What do you think we should put that as? Okay. Here's -2, right? Here's the point. What is the y value of that point? It's like it barely went up. What number would you say that is? Well, 1 would be actually, what? 0.1? That's good. Okay, some of these you have to estimate because it's like you don't know exactly what it is. So we'll put 0.1. That's fine. What about -1? So -1, it goes up a little bit more. Maybe that's like 1/3. We'll do 0.3, whatever. Okay. All right, at 0, what's the y value on that graph? 1. Okay, at 1, what's the y value right here? 3, and then at 2, we have 9. Okay. With a table, you can get an equation of the graph. Okay. So let me show you how it's done. For your function, first we need to figure out A and B. If you remember, A is the y-intercept, and then B is the multiplier. So you tell me, what is A? What is the y-intercept of that graph when x is 0? A is 1. Very good. Okay. Now B, you're going to have to look at that table. How much are the numbers multiplying each time? So like let's start right here. From here to here to here, what are they multiplying by each time? 1 times 3 is 3. 3 times 3 is 9. So the multiplier, the B value, is going to be 3. Okay? That's my rate of exponential growth. That's my B value. Okay? Now here's the deal. If I have A and if I have B, then I can write the equation. If you remember from the front of this page, y equals A times B to the power of x is my equation. So let's write that down. Okay? Y equals A, which is 1, times B, which is 3, to the power of x up top. Okay? So the A is 1 is because it's the y-intercept. It's where it crosses the y-axis. So you can see right there. Good question. Or on a table, you can see it when x is 0, right there. Okay. Now, these next two blanks we already figured out. The starting amount is 1. The rate is 3. Is it growth or decay? Growth, okay. Now these next two, okay, can be kind of tricky. The asymptote. Do you see that that line comes down and it goes almost flat and it doesn't cross the line right here? I want you to draw this asymptote, okay? On the axis. It does not touch this x-axis. Okay? Whenever you write the equation of a horizontal line, an asymptote, it's always going to be y equals a number. Okay? Now you tell me, that horizontal line on the axis, what y value does it go through right there? It's 0. If it's on the axis, it hits 0. Okay? So y equals 0 is the x-axis. On the x-axis. Okay? Now let's talk about domain and range. Do y'all remember what domain and range is from like Algebra 1? Or you've heard it before, hopefully? Okay, so domain, if you look at me, domain is from left to right. How far to the left does it go? How far to the right does it go? And range is from bottom to top. How far down to how far up, okay? So let's think about the domain. How far to the left does it go? Do you see how it's going like this? And it's got an arrowhead, so it's going to keep going forever to the left. And then as it goes up to the right, it's going to keep going up and up and up forever to the right. So both directions, it never stops for domain. So here's what you're going to write. Negative infinity, the sideways 8 looking thing. Less than x, less than positive infinity. Have y'all seen that before with domain and range? Okay, this is inequality notation. Okay. Now the range is different. Check it out. If it's going down like this and it stops and it never crosses that line, what's the furthest down it goes on the y-axis? 0, kinda. So like it never actually touches 0, but it never touches 0, but it's almost there. So here's what we're going to write. 0 less than. Now, if it actually touched 0, we would underline that inequality and it would be equal to. But it's just going to be 0 is less than y. And do you see how it goes up forever to infinity? We're going to put less than infinity. Okay? All right. Now, You're going to need to be able to do this tomorrow on the assignment. Okay, I'm going to let you hold on to these notes. Again, they're notes. Keep them, and tomorrow we'll do more with it.